In this lecture, we will talk about the electric field and electric field intensity. Before we start, make sure to click on the subscribe button to access our many simple and unique lectures for free. We know that every charged particle, whether positive or negative, creates an electric field around it. We also discovered that when we place a test charge inside an electric field, it experiences a force. And depending on the charge, the electric field points outward for positive charges and inward for negative charges. Remember these three key concepts. What is electric field intensity? To understand electric field intensity, imagine a large positive charge, Q. Around this charge, there exists an electric field. Now, let's bring a small positive test charge, Q, inside this electric field. The test charge will experience a force, let's call it F, because it entered the electric field of charge Q. This force, F, experienced by the test charge due to the electric field, is what we call electric field intensity, E. So, electric field intensity is the force experienced by a unit positive charge, like Q, when placed in the electric field. The symbol for electric field intensity is E, and it is measured in Newton per Coulomb. Remember, since force is a vector, electric field intensity is also a vector. Its direction is the same as the direction of the force experienced by the test charge. Difference between electric field and electric field intensity. To differentiate between electric field and electric field intensity, think of the electric field as the region around any charged particle. It's like the area of influence. On the other hand, electric field intensity is the strength of that electric field, the force it exerts on a test charge. So, electric field is the region, and electric field intensity is its strength. Deriving the formula for electric field intensity. Let's derive the formula for electric field intensity. Consider a big positive charge, Q, which creates an electric field around it. Now, bring a positive test charge, Q, inside the electric field of charge Q, at a distance r from its center. As we learned earlier, the electric field intensity, E, is equal to the force, F, experienced by the test charge Q divided by the charge Q itself, E equals F over Q. According to Coulomb's law, the electrostatic force, F, between the test charge Q and a big positive charge Q is given by F equals K into Q slash R squared, where K is Coulomb's constant, approximately 9 into 10 to the power of 9 nm squared C. Now, equating the two expressions for force, we can solve for electric field intensity, E. The formula for electric field intensity, E, is E equals K into Q by R squared. In summary, electric field intensity is the force experienced by a unit positive charge placed in an electric field. Electric field is the region of influence, and electric field intensity is the measure of its strength. We can use Coulomb's law to derive the formula for electric field intensity, which helps us solve various numerical problems.